Hi geometry students, this video is to talk about the properties that are involved in a reflection. So we have our diagram of a reflection shown here, so we're going to talk about all of the properties that are involved. The first property that we see is corresponding angles are congruent to one another. So that word corresponding then is referring to those angles that are connected to each other or would be at almost the same angle if the reflection had happened. So for example, the angle at the top flips over to be the angle at the top on the left and the right. So those angles correspond to one another. They go together. That's what I want you to think of when you hear the word corresponding. So we can mark each set of those angles congruent. So for example, the bottom outside angles are congruent to one another. The top angles are congruent to one another, and the bottom inner angles are also congruent to one another. So we can mark each of those. Pairs. The next property is that the corresponding sides of these two shapes are also congruent to one another. So again, corresponding means the one that go together. So the inside, almost vertical looking side, the horizontal side, and the slanted side are all going to be congruent to one another. So horizontal side first down at the bottom, vertical side as well, and then that slanted side, each has a congruent pair, one on each triangle. Our next property is that the line of reflection is equidistant to each corresponding vertex. So in this one now, the line of reflection is involved as well. When we say equidistant, that means literally equal distance. There's just a fancy word, equidistant, that we can use there. So the diagram example that I'm going to show here is the distance from the vertex that maybe looks like a right angle. We're not sure, it's not marked, but the distance from that vertex to the line of reflection and the distance from the other vertex that maybe looks like a right angle to the line of reflection, they are the same distance away. That distance is preserved when we do that type of reflection. So they are equidistant to the line of reflection in that way, so those two lines would then be congruent to one another. Same would be true for these top vertices and for those outside vertices. If I added all of those lines, it would jumble the image rather than making it more clear, so I have gone ahead and just labeled one, but it is true for all three sets of vertices. And with that, the line of reflection and the lines that would connect those vertices end up being perpendicular. So these purple lines are perpendicular to the line of reflection if we go straight across in that way. So they are perpendicular because we fold across that line of reflection, so that becomes then exact same position across that line, perpendicular to one another. So same would be true for that top vertex and again for that outside vertex, but without jumbling the picture, I've just shown you one. All right, and then the final property for our reflections is that the pre-image and the image have different vertex orders. So pre-image is the before, and the image is what happens afterwards. So in this case, either one could be the pre-image or the image. This could be the pre-image, which we reflected across the line to the image like so, or the one on the left could be the pre-image that we reflected across this line to be the image on the right. Either way. Those pre-image and image are going to have different vertex order for one another. So for example, I'm going to go ahead and say that this right here is my pre-image, the image or the diagram that's on the right. So it has the vertices A, B, and C like so. When I flip that shape over and do that reflection is then I'm going to use the prime notation. So it has A prime, B prime, C prime in this way. So having a different vertex order, you get to decide how you want to read that order, but let's pretend for a moment that I'm going to read clockwise around my shape. So in my first triangle, the one to the right, when I read clockwise, I read A, then B, then C, back around to A. If I read in that same kind of clockwise direction on the triangle that's on the left, I would read A prime, C prime, then B prime. So it changed order. C came after A now instead of B. So the order of those vertices has shifted. And those are the properties of the reflections. In the end, your diagram will have all of these markings. You can choose to annotate in whatever way you like to not gunk up this diagram too much. But those are all of our properties.